In this activity, we will be verifying the Pythagoras theorem. So the objective of this activity is to verify the Pythagoras theorem by performing an activity, and the activity will involve some paper cutting. So let's see the concept in hand first. Whenever we have a right angle triangle like this, in which we label the arms forming the 90-degree angle as A and B, and the hypotenuse of length C, then the square of the hypotenuse is equal to the sum of squares of the other two sides. We all know that this is the Pythagoras theorem. Now, after having known what is Pythagoras theorem, we must know that there are so many different ways through which we can verify this, and one of these ways is discussed in this activity. You know, this can be verified using a square sheet of paper and dividing that into 4 right triangles and 1 square. Yes, 4 right triangles and 1 square will verify the Pythagoras theorem in a right angle triangle. So let's see what are the material required for this activity. We require colored glazed papers so that we can make cutouts of all those shapes which I discussed in the concept, a pair of scissors, a geometry box, and Fevicol to do the pasting work. So let's see how all these materials can be used for carrying out this particular activity.
For verifying Pythagoras theorem, you need to first take a cutout of the fluorescent sheet in the form of a right angled triangle. You can see in this right angled triangle, the base is taken as A and the perpendicular is taken as B. For simplicity's sake, you can take the value of A to be larger than B. However, you can take otherwise also, it will work. But if you take A as larger than B and hypotenuse as C, then you need to duplicate this figure and make 3 more copies of this particular figure. So we have 4 identical right angled triangles. Now you need to calculate the difference between A and B, the base and the perpendicular. Whatever is the value of A minus B, you have to cut a square of that measurement. That means the side of the square should be equal to the difference between the base and perpendicular of the right angled triangles. After this, these 5 shapes are going to be arranged in such a way that they form parts of a big square. You can see in this particular square, the big square, there are 4 right triangles which exactly resemble the 4 triangles which we had cut out, and the one square is exactly in the middle. So when we do some calculations, we can actually get to the Pythagoras theorem. How do we do that? Now this side was B and this side was A. And now we need to find how much is this side. This is B again, and therefore the side of the square was A minus B. So let us calculate the areas 1, 2, 3, 4. So area of the big square will be equal to half base into height, that is the area of one right angle triangle, times that by 4. This will give us the combined area of the 4 triangles, and add what? Add the square of A minus B, that is the area of the square in the middle. So A minus B square. So if you expand this 2 cancels out and you have 2AB plus, if you expand this, A square plus B square minus 2AB. So the 2AB cancels out and you have the area of the big square as A square plus B square. What will this area A square plus B square be equal to? It is equal to the area of big square, right? So what is the side of the big square? When we cut out the right angle triangle, we took the hypotenuse as C, and therefore the side of the big square is C, and therefore the area of the big square is C square. So C square equal to A square plus B square, which is the exact Pythagoras theorem applied to a right angle triangle. C square, the square of the hypotenuse, is equal to A square plus B square, that is sum of squares of the other two sides. And that completes our activity on Pythagoras theorem.